lesson on finding derivatives of trigonometric functions. So we're going to introduce the derivatives of the sine and cosine function and then get into the derivatives of the rest of the 6 trig functions and just talk a little bit about finding some higher order derivatives for sine. Okay, so let's start by looking at the derivatives of sine and cosine. So these are the most basic ones that we'll be looking at. All right, and again, this idea is if you are interested in the proof behind any of this stuff, please feel free to read OpenStax or Calculus for Dummies. It'll give you a more detailed description on how they came about finding that the derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. So we're going to use those going forward. All right, so let's find the derivative of this function, which is 5x cubed times the sine of x. So we're going to use the last slide that told us the derivative of the sine of x is cosine of x, and our understanding from the previous lesson about the product rule to find this derivative. So I'm going to do f prime of x equals the derivative, so d dx, of 5x cubed times the sine of x, plus d dx of sine of x times 5x cubed. All right, so that's the product rule. The derivative of 5x cubed is 15x squared times the sine of x, plus the derivative of the sine of x is cosine of x. So this is going to be cosine of x times 5x cubed. So our answer for f prime of x is going to be 15x squared times the sine of x plus 5x cubed times the cosine of x. All right, so that is it. All right, let's do the next one. All right, we're going to be finding the derivative of this function g of x that says cosine of x over 4x squared. So I'm going to use the quotient rule, like we talked about last lesson, to help me find the derivative of g of x. So g prime of x equals d dx of the numerator times the denominator minus d dx of the denominator times the numerator all over the denominator squared. All right, so let's find the derivative of cosine of x. The derivative of cosine of x using the slide above this is negative sine of x. So negative sine of x times 4x squared minus the derivative of 4x squared is going to be 8x. So 8x times the cosine of x all over 16x to the 4th power. So squaring the 4x squared. Let's clean it up a little bit. Now I think you'll see we can do some stuff. So negative 4x squared times the sine of x minus 8x cosine of x all over 16x to the 4th power. Now this is the answer, but I'm not going to leave it like that because I can factor in the numerator. I can factor out a negative 4 and an x. So if I factor out negative 4x, I'm left with x times the sine of x plus 2 times the cosine of x all over 16x to the 4th power. So go ahead and cross out 4 over 16 to become 1/4, and the x and the x over x to the 4th power is going to leave x cubed in the bottom. So we have negative, or the opposite of x, times the sine of x plus 2 times the cosine of x all over 4x cubed. So that is my derivative of g of x. Okay? All right, let's keep going. Now, you're going to see a lot of kind of similarities to stuff that we've done in the first unit and also with your time in trigonometry last year. So this example says we have a particle moving along a coordinate axis in such a way that its position at time t is given by this function 2 times the sine of t minus t. And it wants us to find at what times is the particle at rest. Now this equation, or I should say this question, when it says at what times is the particle at rest, it's essentially asking for when is the speed, which is the velocity, the absolute value of the velocity, when is the velocity of this particle 0? Now, we've talked about how if you give you the position function, to find the velocity function, so v of t, is the first derivative of the position function. So if I find the derivative of s of t, that will give me the velocity function. So that means I'm going to do d dx of 2 sine t minus t. Show some work here. I'm going to move that 2 in front to be 2 times d dx of sine t minus d dx of t. All right, we know the derivative of sine is cosine. So that's 2 cosine t, and the derivative of t is just going to be 1. All right, so this is the velocity function. Now I'm trying to figure out where is the speed or the velocity going to be 0. So I'm going to set this velocity function equal to 0. Okay, solve for t. That's a positive 1. Divide by 2. Get the cosine of t equals 1/2. All right, so what I'm asking my brain is cosine to the negative first power of 1/2 equals t. So can I think of angles that when I take the cosine of them, I get 1/2? All right, so this is, you copy down that box for unit 1 and you memorize those, or at least you memorized it enough to put on the test. You can refer back to that. I can go back to my trig. Let's see if I had it here. I got somewhere. Let me find it. My trig formula sheet. No, I know where it is. It's in my pre-cal class in trigonometry. There it is. All right, so you can refer back to this if you want. All right, but essentially, this is something that I have memorized, but I'm talking about this kind of at the bottom here, or the middle to the bottom. And I'm looking for the cosine of either pi over 6, pi over 4, or pi over 3 to be equal to 1/2. You'll notice the cosine of pi over 3 is 1/2. So my answer here, or one of them I should say, is t equals pi over 3. Now, it does say in the problem that we're looking for values for t that are between 0 and 2 pi. So this is not the only value that will work, right? If you draw your coordinates, right, here is pi over 3. But if I think of my, all students take classes, the cosine is also positive in the 4th quadrant. So the other one is going to be 5 pi over 3. So these are the 2 times where the particle is at rest. And we'll go over more of that in class if you need more of a breakdown and explanation for this question. Okay, now we're going to actually find the derivative of the tangent function. We're going to solve for it ourselves based on our understanding of one trig identity, as well as our understanding of the quotient rule. And then we'll look at the table for the other 3, the reciprocal ones, right, of cosine, sine, and tangent, secant, cosecant, and cotangent. Okay, so I'm going to rewrite this as f of x equals sine of x over the cosine of x. All right. Now, when I do that, you'll notice that we have division. All right, and so when I have division, I'm going to use the quotient rule. So I'm going to do f prime of x equals d dx of the numerator, which is sine x, times the denominator, cosine x, minus d dx of the denominator, that's cosine x, times the numerator, sine of x, all over cosine x squared. Okay, so the derivative of sine is cosine. That's going to be cosine of x times cosine of x. The derivative of cosine of x is the opposite of sine of x. So I'm going to write the opposite of, that's going to be negative sine of x times sine of x, all over cosine squared x. All right. Now that's going to become cosine squared x, and right, subtracting a negative here is going to be plus sine squared x all over cosine squared x. And I know it's been a while, but I can pull up the trig identities here. We have cosine squared plus sine squared equals 1, which is right there. So I'm going to rewrite the numerator as 1. And this is just a reciprocal 1 over cosine squared. We can do the reciprocal of 1 over cosine. And the reciprocal of cosine is secant. So the derivative of tangent of x is secant squared x. Again, you don't have to know how to do this. I'm just showing you how we can use our understanding of trig from last year and what you just learned about the quotient rule to find it out. All right, so you look over here and it's in the box, so no stressing, right? These are the derivatives of the remaining functions. So you've got, don't forget, the derivative of sine of x is cosine of x, and the derivative of cosine of x is the opposite of the sine of x. All right, so those are the 6 that we'll be using. Okay, let's go to this one. It says to find the equation of a line that's tangent to the graph, f of x equals cotangent of x at x equals pi over 4. Now, we did a problem just like this in lesson 3.3. Right? The only difference now is that we have to deal with a trig function as opposed to just I believe it was a quadratic function. Okay, so it's the same process. The work might feel a little bit more challenging because it is involving some trigonometry. So the first step is we're ultimately going to use point slope form, right? So point slope form, which is y minus y sub 1 equals m times x minus x sub 1. So I need a point. They gave me the x value, so I'm going to plug in pi over 4 into this function, so the cotangent of pi over 4, to get my y value. Now, if I'm using my formula sheet, right, if I go over here, my formula sheet, the tangent of pi over 4 is 1, right? The tangent of pi over 4 is 1, but we want cotangent, and cotangent means you just have to flip it. Well, if you do the reciprocal of 1, right, 1 over 1 is still just 1. So this is actually going to be 1. So my point is going to be pi over 4 comma 1, right? This is my point. All right, now I need to find the slope. The way we're going to do this is we're going to find the derivative of f of x, and then we're going to plug in the x value that's given to us to find the slope of the line that's tangent to this curve at that point. Okay, so let's find f prime of x is d dx of the cotangent of x. All right, if I go over to cotangent of x, it says it's negative cosecant squared x. So I'm going to write down negative cosecant squared x. All right, so that is our derivative. Now I need to plug in, right? I need to plug in pi over 4. So I'm doing f prime of pi over 4, which is the opposite of cosecant squared of pi over 4. Now, if you want to plug this in the decimals, that's fine. I'm not going to, but you absolutely could just type this in. It will spit out the value. The way that I'm going to do it is I'm going to rewrite this as the opposite of cosecant of pi over 4 squared. All right, so I'm going to find the cosecant of pi over 4, then square it, and then do the opposite of that. All right, so let me go to my formula sheet. All right, remember cosecant, the reciprocal cosecant is sine. So the sine of pi over 4 is the square root of 2 over 2. So if I write this down, do a little work over here, right? The reciprocal of the square root of 2 over 2 is going to be 2 over the square root of 2. So I have the opposite of 2 over the square root of 2 squared. Let's square that first. So the opposite of 2 squared is 4. And then the square root of 2 squared is 2. Well, 4 divided by 2 is 2. The opposite of 2 is negative 2. So our slope, right, this right here, is the slope of our tangent line. So now I'm going to use point slope form to find the line. So we have y minus y sub 1 equals m times x minus x sub 1. So y minus 1 equals negative 2 times x minus pi over 4. All right, so I'm going to distribute and get negative 2x plus, and if I multiply negative 2 times a negative, that's a positive, negative 2, or 2 times pi is 2 pi. 2 pi over 4 is going to be reduced to pi over 2. So the answer is negative 2x plus 1 plus pi over 2. All right, let me plot this for you and see if this will help your brain when I show you on Desmos. All right, so I'm going to first plot the cotangent of x, okay? That was our original function. So here's how it looks. I'm going to change my step to be pi over 4, right? That's my x value. So you can see the point we found when we plugged in pi over 4, we got pi over 4, comma 1. Where are you? Almost there. Almost really close. Anyway, it's right there. I'm going to zoom in for you. Right there. Pi over 4, comma 1. Anyway, now I'm going to type in the line that we found, which was negative 2x plus 1 plus pi over 2. And you can see my blue line is tangent to this cotangent. That's weird to say, I know, but our blue line is tangent to this cotangent curve, all right, at x equals pi over 4 right there. Okay, so I'll zoom out. Maybe it's easier to zoom out and see it. Either way, this is graphically what we just found. Okay, let's keep going. We're almost there. All right, let's find the derivative of this function. Again, we're kind of just doing a variation on the same theme where we're going to be having the sum rule and then using the product rule within that. But what makes it a little trickier is the fact that we have some trig functions. So f prime of x is d dx of this whole thing. So cosecant x plus x times tangent of x. Now, I'm going to use the sum rule first. So I'm going to do d dx of cosecant x plus d dx of x times the tangent of x. Now, you should notice the piece on the right, I'm going to need to use the product rule to expand that. Very similar to a problem that we did earlier in a previous lesson. So we have the derivative of cosecant x, which if you want to write that down now, you can, right? Just look at your table. Plus, I'll put it in brackets, d dx of x times tangent of x plus d dx of tangent of x times x. Okay, so let's find the derivative of cosecant is negative cosecant x cotangent x. So negative cosecant x cotangent x. I'll make sure I got that right. Yes. All right, I know the derivative of x is 1. So that's going to be 1 times the tangent of x. And then plus the derivative of tangent is secant squared x times that original x. All right, I'm going to clean it up to write the answer. So f prime of x equals the opposite of cosecant x cotangent x plus tangent x plus x times secant squared x. So there we go. That is the derivative. All right, last few things. This last one is, I'm going to show you the derivatives of sine. It develops a pattern. So if we start with y equals the sine of x, right? dy dx, which is the first derivative, is cosine of x. We already know that. Now, if I want to find the second derivative, right, d squared y over dx squared, that's going to be the derivative of cosine, which is the opposite of sine of x. Then I want to do the third derivative, so d cubed y over dx cubed. I get the derivative of sine, which is cosine, but you have the opposite of that, so it's going to be the opposite of cosine x. And then finally, to get it kind of back to full circle, you have the fourth derivative, which is going to be derivative of cosine, which is negative sine x, but it's the opposite of that, which gets you back to positive sine x. So the way that I do these kind of questions is every fourth derivative of sine is going to go back to sine, right? So the idea is it's kind of like a pattern. So where you are in the steps, all right, you've got the original, right? So 1, 2, 3, 4. Let me do it this way. Change colors. So you've got like your starting value, then your first derivative, second derivative, third derivative, and you'll notice the fourth derivative just starts the cycle over. So this is actually, it's not going to be number 5. It's going to go back to 1. So where you are on the pattern will tell you what you're going to have. Now, they have a little formula down here. You can use that if you want, but I'm going to show you with my next example kind of how I do it. All right, so it says to find the 74th derivative of the sine of x, okay? Again, it's not really obviously something you would ever worry about in life, but we'll show you how to do it. So first thing I notice is if I divide 74 divided by 4, it's not a whole number, right? I get 18.5. So then I'm like, all right, well, what's the value below 74 that's divisible by 4? And 72 is divisible by 4. So if this was the 72nd derivative of sine of x, it would be the sine of x. So think of that as like the starting point. So then the 73rd derivative of sine of x would be the next step. Let me kind of zoom out so you can kind of see the order that I'm going here. Right, so that's our beginning, is sine of x. Then my second step is going to be, this is cosine. And now we're at the one that I want, which is the 74th one. All right, so that's going to be this next step here, which is after cosine, it goes to the opposite of sine of x. All right, so that's kind of how I set it up when I do this. Just figure out what part of the pattern am I on. All right? Okay, let's do one more and then we'll be done. So we have a particle moves along a coordinate axis in such a way that its position at time t is given by s of t equals 2 minus the sine of t. We're trying to find the velocity at pi over 4 and the acceleration when time is pi over 4. Compare these values and decide whether the particle is speeding up or slowing down. So again, we're starting with a position function, s of t. So to find the velocity, we're going to find the first derivative of s of t. So that's going to be d dx of 2 minus the sine of t. Well, we know the derivative of 2 will be nothing. All right, so really it's the derivative of negative sine of t. Well, the derivative of sine is cosine, but this is going to be minus the cosine of t. So there's our velocity. Let's plug in pi over 4. So the opposite of the cosine of pi over 4. Now we've done this before. If I look at my formula sheet, the cosine of pi over 4 is the square root of 2 over 2. All right, but that's not the answer because it wants the opposite of that. So it's the opposite of the square root of 2 over 2. So what I notice is that my velocity is negative. And like a question we did last week, that means your particle is moving from right to left. Now let's find the acceleration. The acceleration is the derivative of the velocity function. So I'm doing d dx of the opposite of cosine of t. Well, we know the derivative of the cosine function is going to be negative sine. If you need to go back and look, you can. Right here, derivative of cosine is the opposite of sine. But remember, we already have a negative in there, so the opposite of sine or excuse me, let's go back and show you. So it's negative sign, but we already have a negative, so it's the opposite of a negative, which is a positive. So the acceleration function is the sine of t. So let's plug in pi over 4 to the acceleration and do the sine of pi over 4. Here's my formula sheet. The sine of pi over 4 is the square root of 2 over 2. And this one is going to be positive. Okay, so acceleration. That's not how you spell it. 2 R's, right? No, I was right. 2 C's. There we go. Is positive. Now, we had this exact same scenario happen in a previous lesson where velocity is negative, so our particle is moving from right to left. But the acceleration is positive, so it's actually going the opposite direction. So if you're accelerating in the opposite direction of the direction that you're moving, that means you're going to be slowing down. So this particle is slowing down. All right? So hopefully this wasn't too bad. I mean, this was really just an extension of the differentiation rules lesson. And the reason that made it a little tougher was the fact that we're throwing in the idea that we have to take the derivatives of our trig functions. All right, but hopefully you have time to practice, and good luck.